In this video, I want to cover implicit differentiation. And up until now, you've probably been doing explicit differentiation, which is just the normal kind of differentiation, such as y is equal to some x expression, so y is equal to x cubed. That would be a normal explicit differentiation problem. But what if your function is not written as y equals some x expression? You'll have to use implicit differentiation, such as, for example, this problem. X cubed plus y cubed is equal to 8. So we can't use explicit differentiation for this problem. We'll have to do it implicitly. And the way we want to start is we're going to differentiate both sides with respect to x. So the derivative of x cubed is 3x squared plus the derivative of y cubed is 3y squared. But this is where things change. Anytime you take the derivative of a y variable, you must also then multiply it by dy dx. Okay. And then it just goes on from there. Is equal to the derivative of 8 is equal to 0. So now we're done with the first part of the problem. And the second part of the problem is we're going to have to solve for dy dx. Okay, so the way we're going to do it is first we're going to subtract 3x squared from both sides. These will cancel. This will leave us with 3y squared times dy dx is equal to negative 3x squared. And then all we have to do from here is divide by 3y squared. So divide by 3y squared, divide by 3y squared. This is going to leave us with dy dx is equal to negative 3x squared over 3y squared. And the 3's will cancel, so in simplest form, dy dx is going to be equal to negative x squared over y squared. And this is the answer to this problem. So for problem number 2, we're going to have x squared plus y squared is equal to 36. Find dy dx. Okay, so we're going to have to do this implicitly, and we're going to do it the same way. We're going to first differentiate both sides with respect to x. So the derivative of x squared by the power rule is equal to 2x plus the derivative of y squared is 2y, but we just took the derivative of a y variable, so we must also now multiply by dy dx is equal to the derivative of 36 is 0, and now we have taken the derivative of both sides with respect to x. We must now solve for dy dx. So we're just going to subtract 2x from both sides. It's going to cancel. This is going to leave us with 2y times dy dx is equal to negative 2x. Now we have to divide by 2y to isolate dy dx. So 2y. The 2's will cancel. So this is going to leave us with dy dx is equal to negative x over y. And that is the answer to this problem. So for problem number 3, we're going to start the same way. We need to differentiate with respect to x on both sides. So by the power rule, the derivative of x squared is 2x plus, and then we come across 2xy, or 2x times y. And whenever you see x and y combined, you're going to need to use the product rule to take the derivative. If you're doing implicit differentiation, you should already know how to use the product rule. But to use the product rule, you differentiate one part and then keep the other part the same. So we'll do it over here. This is going to be 2x times y, and it's the derivative of the first, so 2 times the second plus the first times the derivative of the second. And the derivative of y is just 1, But since we're taking the derivative of y, we have to also multiply it by dy dx. It'll be 1 dy dx, and since it's just 1, I'm not going to write it. So dy dx. The reason we didn't multiply this y by dy dx is because we did not take the derivative of this y. So this is going to be plus 2y plus 2x times dy dx plus, and then we're on to our third term. So we're going to take the derivative using the power rule. So it's going to be 2y. But we just multiplied by a y or we just took the derivative of a y variable, so we have to also multiply by dy dx is equal to, and the derivative of 5 is just 0. So the first part of this problem is complete. We have taken the derivative of both sides with respect to x, and now we just need to isolate dy dx. So the first thing we're going to do is we're going to get all the dy dx's on one side. So we're going to move these terms right here to the right hand side, and that's going to leave us with 2x dy times dy dx plus 2y times dy dx is equal to negative 2x, because we subtracted 2x from this side, and negative 2y because we did the same thing here. So now if you look at this, we have all our dy dx's on one side. We now can see that we have all these two coefficients. We can actually divide this whole thing by 2 and cross them out, cancel them. So this will be equal to x times dy dx plus y times dy dx is equal to negative x minus y. So what we're going to need to do is pull out a dy dx on the left hand side, so we just have one of them. We can just find dy dx. So we're going to pull out a dy dx on the left hand side. So dy dx times x plus y is equal to negative x minus y. On the right hand side, we can pull out a 1 just to make it look like x plus y. So if we pull out a negative 1 on the right hand side, this will be dy dx times x plus y is equal to negative 1 times x plus y. So now when we divide by x plus y, it cancels. So in order to get dy dx by itself, to isolate it, we must divide by x plus y on both sides. These x plus y's cancel, and we are left with dy dx is equal to negative 1. And that is the answer to this problem. So for this problem, we're going to go about it the same way. We're going to differentiate each side with respect to x. So the derivative of sine is cosine minus, and now we ran into a problem where we needed to use the product rule. So we're going to write it over here. So this is x squared times y. So we're going to take the derivative of the first, so 2x, times the second, plus the first times the derivative of the second. And the derivative of y is just 1, so we don't need to write 1, but we do need to multiply it by dy dx. And we didn't multiply this y by dy dx because we didn't take the derivative of it. So we're going to write this derivative in here. So 2xy plus x squared times dy dx plus, and then the derivative of y is just 1, so we don't need to write it, but multiplied by dy dx is equal to, and the derivative of 10 is just 10, So now we're done with the first part. We have taken the derivative of both sides with respect to x. Now we need to simplify this up a little bit. We need to distribute the negative. So this is going to be cosine x minus 2xy minus x squared times dy dx plus dy dx is equal to 10. So now we need to isolate the dy dx's on the left hand side. So we're going to move this part of the equation over to the right by adding and subtracting them off. So this is going to be equal to negative x squared dy dx plus dy dx is equal to 10 minus cosine x plus 2xy. And that is that part of the equation. So what we can do from here is we can actually pull out a dy dx on the left hand side times negative x squared plus 1 is equal to 10 minus cosine x plus 2xy. And from here, all we have to do is just divide by negative x squared plus 1 to isolate dy dx. So divide by negative x squared plus 1. Do the same thing here. Negative x squared plus 1. So the answer to this problem is dy dx is equal to 10 minus cosine x plus 2xy divided by negative x squared plus 1. And that is the answer to this problem.